This is the Introduction to Trigonometry, Lesson 1AA. And today we're going to talk about finding the length of an arc of a circle. Now, there's some concepts we have to really explain here. And what I did, I drew two figures here to try to best describe certain specifics here. For figure one, you have a central angle that is, of course, is positive, whose vertex is at the center of the circle here, right there. And the rays of the central angle subtends or intersects an arc on the circle. So it like hits these points right here on the circle. And if the radius of the circle is r, and the length of the arc subtended by the central angle is also r, then the measure of the angle is right here 1 radian. If you notice right here in the figure. So the angle is this arc length is subtended by here. We'll talk about subtend in just a few moments here. If you look at the second diagram here, for a circle now, of course, with the radius 1. Now we have the actual unit here, or dimension here, 1 for the radius. And the rays, remember from the beginning of our lessons, the rays which make up an angle of the central angle with the measure of 1 radius subtends the arc of length what? 1. So you have a radius here of 1, and you have a radius there of 1. That makes an angle. That subtends this arc here. And this distance from here to here, which is the radius, which is 1, and distance from here to here is 1, that arc will be also, the distance or the length of the arc will be 1. For a circle now of the radius 3 from here to here is 3, and of course from this point to this point also 3. Well, the rays of the central angle here, believe it or not, this angle is subtended by this here as well. Right? So we're going to talk about subtend right now. Let's look at the definition. In geometry, an angle subtended by an arc, line, or other curve is one whose two rays pass through the endpoints of the arc, as you see right here in this diagram, and also in this diagram as well. Now, also too, for the second definition, to be opposite to and extend from one side to the other of an example. Here, for example, of that is, you have the hypotenuse here subtends a right angle. So it's saying an opposite from that. Let's look at this too. You see you, and this is like maybe a planet or so, and this might be the sun. That shows that the angle from your viewpoint will create some sort of distance from the point, from your vanishing point to the object, if you will. So if I'm standing here, if you will, and I'm looking at this door here, face the door there real quick. So you see the door from here, from where my eyes are, there's an angle hitting the top of the door and also hitting the bottom of the door. That's subtended. So here it'll be an angle. Here's an angle. Here's a good example for a tree. This guy looking at the tree, right? Here the subtend angle of the tree, basically from the person's point of view, is what? Is some sort of angle, let's say 30 degrees. And when you look at this here, when you look at the moon, and from the moon to maybe the sun or some other planet, that angle is subtended, right? Causing a length, an arc length there. So this will cause some sort of arc length here and here. But it kind of gives you some sort of angle reading from there, right? So from the eye level, from the point of view, from Earth to the moon, and then it continue on to some other planet or something, we'll have some sort of angle from that viewpoint, if you will. We're explaining that right. So basically, this is what we're dealing with here. Okay, so if we come over here to the other side, we're going to be talking about some things here. We're going to be talking about the central angle. Look at this diagram here. Look at this diagram. We have central angle theta and theta sub 1, which subtends the arc. It subtends the arc, right? S, and also S of 1. The ratios of the measure of the angles are equal to the ratios of the corresponding lengths of the arc subtended by the angle. So this length here, when this hits here, of course it intersects, right? Or hit these points, right? Then this subtended angle is causing a length here in the arc. Same with on this side. Because this is subtended to this angle, and this arc is subtended to that angle. So we have a ratio of theta divided by theta sub 1 is equal to S over S of 1. Now suppose theta of 1 is equal to 1 radian, and the length S is subtended by the central angle theta sub 1 equal to 1 radian is equal to the radius R of the circle. Now, and S of 1 is equal to R. So we're plugging in the values where they belong to, and then we're going to cross multiply and solve for S, excuse me. We're going to solve for S. So here we have created, or we have derived, the arc length of the circle, an arc length. So for a circle of a radius R, a central angle of R, or theta radian, subtends an arc whose length is S. So we see this. Now look at this very closely. We got thetas of radius over 1 radian equal to S length units and R length units. So this is the relationship right here that we get. And of course, gets this the relationship still also as well. Theta is dimensionless, however, it's in fact measured in radians. So let's do a problem. So we're going to write a problem on the board. And if you could kind of look at some of the diagrams here and take notes if you can. Because we're going to do a problem, and I'm going to show you how to calculate the arc length of a circle. So, let's look at this problem. We want to find the length of the arc of a circle of radius radius 2 meters, that is subtended by a central angle. Central angle of 0.25 radians. Okay? We want to find the length of the arc of the circle with the radius of 2 meters. The radius is equal to 2 meters. And then what else do we have? The angle is going to be 0.25. So we set up our formula. S is equal to R times what? Theta. So in this case, what we'll do is we'll plug in the values appropriately, 0.25, and then we'll come up with an answer. The answer will be 0.5 meters. So basically here what you'll have is this problem here. Basically you got this length, this is the radius, 2 there, and of course if it's 2 from this point to that point, of course it's going to be the same from this point to that point, from this point to that point. This is subtending, intersecting, and also opposite of, so this is subtending, right? So this is going to be, once you do this and you calculate this, so this is going to be 0.25, so your arc length here is going to be what? 0.5 meters. That will conclude our lesson on finding the length of an arc of a circle.